Gotta go quick. Okay, so now function notation. Again, I've done a lot of that in 30-1 and 30-1. Just finished it, right? Now, when you have a function, f of x, the answer is the output. Whatever you put into the brackets is your input. Okay? Not that complicated. I mean, even if we had, let's just do one of them. So if here's my equation, and I'm going to put f of 2x, that would just be 2x minus 1 squared minus 3 times 2x minus 1 plus 5. Okay, and then it's just a matter of foiling this. This would be 4x squared minus 4x plus 1. Get rid of the brackets here, minus 6x plus 3 plus 5. Get it all together, 4x squared minus 4x minus 6x minus 10x. And 1 plus 4 is, and then 9. Okay. So all I did was put 2x minus 1 into the function. Okay. That might have been one of the classes you missed in 30-1.
I don't remember anything.
Yeah, well. Okay. Now, this one here, just for sake of time, we won't go through and do all the work. But if we have f of x and we have g of x and we have 6 f of 0, take the entire function, multiply by 6, and then just put the input into the equation, minus 10 times g of x, which is g of negative 1. So that's going to be 5 minus 3 times negative 1 squared. Actually, we can finish this one. It's not too tough. Okay, so this is going to be 6 times negative 7 minus 10 times 5 minus 3, which is 2. Negative 42 minus 20 is negative 62. Okay, so, and again, both classes, this should be review. If you have f plus g of x, this means f of x plus g of x. F minus g of x is f of x minus g of x. If you have f times g of x, that's f of x times g of x. And f over g of x is the same thing as f of x over g of x. Now, the domain will be the intersection of the two. Okay? So the domain of f of x and the domain of g of x, the intersection of the two, when you combine them, will be the new domain. Okay? Because you can't, because they're together now, whatever used to work in the other, in the one, may not work when they're together now, because maybe it's a non-permissible, and once they join up, if it's a non-permissible in one, the other is not allowed to use it. Okay? So let's do an example here. Okay, so this one, do you see how maybe, well, f of x, let's just actually say this was f of x, and this was g of x. They may have had their own separate domains, but now the domains affect the entire question. So if we find out the domain of this one, x cannot equal 7. And the domain of this one, x cannot equal -3/5. Okay, so if I was to just do a number line, and if I put -3/5 down and 7 on my number line, now the domain of f of x was, this is the domain of f of x. See, f of x had it pretty good at one time. It only had one thing that didn't work. But now, when it joins up with g of x, which has this domain, their new domain becomes what they share. Okay, so they would share this part, and this part. See, they don't share, they both don't have the same domain here, and they both don't have the same domain here. It's what they have duplicate. Okay, so I'm actually going to write this right underneath to show you how the domain should look. So this is -∞, comma, -3/5, union, -3/5, comma 7, union 7, comma infinity. Okay, let's do a couple more so you can really see how this works. Okay, so this would be like f of x over g of x. So for f of x, let's just talk about it. That is root 9 minus x squared. So now 9 minus x squared has to be greater or equal to 0. Because you're not allowed to have negatives under a radical sign. Negative x squared is going to be greater or equal to -9. I'm going to divide by -1. So x squared has to be less than or equal to 9. You wouldn't square root this because you'd want to think about what values would work. So the values that would work would be between -3 and 3. Okay, so that's the domain that f of x used to have, but then it got divided by g of x. Okay, so it may not get to have all those values anymore. And that's what we've got to figure out the intersection now. So g of x equals root x. Now, for this one, x has to be greater than 0. This one's tricky because when I first looked at this, I thought x can be greater or equal to 0. But g of x cannot equal 0, correct? Why? Because it's on the bottom. So g of x cannot equal 0. Therefore, the square root of x cannot be x is greater or equal to 0, because if it equals 0, the whole thing doesn't work. Okay? So this one's a pretty simple number line. We're going like that, right? Now, the domain is the intersection of them. Okay, so to do this, the first one is negative 3 and 3. It's right there. Okay, the domain of g of x is 0 and greater. So what they share is just that, right? So the domain would be round bracket 0, comma 3. Square bracket. Okay? So that's all that we don't really get into that as much in 30-1. We just do the functions and stuff, and then you can find out the domain at the end. But just realize that it's always going to be the intersection of the two domains. Okay? Now, f of g of x means put g of x inside of f of x. Okay? And just always note that could happen. It shouldn't say, you know, but this should say for most cases. There is a couple cases where, especially if f of x and g of x were the same. Okay, good. Okay, so let's just do one of these. F of g of x. We don't need to do them both. Let's do the first one. This says take g of x and put it into x. Okay, so this is going to be 5 times 1 minus x squared minus 7. 5 minus 5x squared minus 7 is negative 5x squared minus 2. And it didn't ask us for domain range, so. Okay. We're going to skip this too. And let's get to odd and even functions. Okay. Now, this again will come into play a lot more when we're graphing, using our derivatives and second derivatives and integrals and x, y intercepts and all those things. This is just another piece of evidence of what does this thing look like. Now, even functions are when f of negative x equals f of x. Okay? Now this looks way more complicated than it is, but when you see how it works, as this example, see 4x squared minus 5 is considered an even function. Okay? Why is it considered an even function? Well, if you put f of x in there, or sorry, if you put a negative x in there, you actually get back your original function. Okay? So that's how you test it. If you put x and replace it with negative x, and you get the original function back, then it is an even function. All even functions are perfect symmetrical reflections around the y-axis. So you can see by the picture that if you did a reflection on the y-axis of that, you should get the same graph. So it only makes sense that when you square this, okay, you get the same answer. Okay, so that's what an even function is, and we're going to do more examples. An odd function is, if you put negative x in, you get negative f of x out. Okay, now these are symmetrical about the origin. So if you were to rotate 180 degrees, it would be the same picture, okay? It's also the same thing as reflected on X, then
Can all grade child
reflected
singing
on
serenade
Y.
come to the atrium, please? Thank you.
Okay. So here's the function that is odd. X cubed plus 7x. Okay? If you plug in negative x, this gives you negative x cubed minus 7x. If you take out a negative, that gives you x cubed plus 7x. Do you see that f of negative x, or sorry, yeah, f of negative x equals negative f of x. So if that is the case, that is an odd function. Okay? Cubed to the 5th to the 7th, yep. No, no. That's definitely, you know, or with an x squared, I would be thinking that's probably an even function, but test it. Okay? Yeah, we just did an odd. No, shouldn't. Okay, so x squared, so you first want to take your x and replace it with negative x, and then you get equals negative x squared plus 3 equals x squared plus 3. Okay, so I got back my original function. So f of negative x equals f of x. So it is even, which means it is symmetrical about the y-axis. Okay, x squared, we know what that looks like. X squared plus 3 would be up here. And that makes sense that that would be symmetrical about the y-axis. Okay, so here's B. Now B, we don't know what it is. We'll try it out, see what comes to. So that's negative x plus 3 squared. Remember, this equals negative x plus 3 times negative x plus 3. Okay, now we would want to be inclined right now to, hey, factor it out, do FOIL on it. But then I want to see if I FOIL it, then I'm very far from even looking like this. So the way you want to do this one is to see if it's even or odd, is actually take a negative out of the first set of brackets, and that would be x minus 3. So then you take a negative, actually let's take a negative 1 out of the next set, that would be x minus 3. Now if you multiply the negative and a negative together, you get a positive, and then that would just be x minus 3 squared. So we didn't get negative f of x, and we didn't get f of x. So therefore it is neither. Actually, let's write this statement. Well, let's just write neither. Okay, and I want you to see what the graph looks like. That's x plus 3 squared. Now we know what x squared looks like. This is a horizontal transformation 3 units to the left, right? So that would be, as you see, that's not symmetrical about the y-axis. Okay, so you shouldn't get, if you did a reflection, Well, you're not on the y-axis. If you did a reflection on the y-axis, you get this. So that is not the same graph, okay? And that is x minus 3 squared. Okay. This one has a cube on it, so I might be expecting. So this is good. Let's try what happens if I put negative x in. That's 2 times negative x cubed. That's the same thing as negative 2x cubed. So f of negative x equals negative f of x. Okay, so this is an odd function. It is symmetrical. About the origin. What's the question? Right there? Yep. F of negative x equals. Okay, and just for interest's sake, this is what the graph looks like. Okay, so if you were to do a 180 on it or a reflection on the x, then reflection on the y, that's what you get. So homework 2C, 4, 5C, 6E, 7A, and 8A, B, C, and D.